Have you ever wondered what goes on behind the scenes at a waste-to-energy facility? Here's your chance to see the science behind the stack. Once trucks arrive, they are weighed and checked in before heading inside to the tipping hall. The waste is unloaded onto the tipping floor and visually inspected for any unacceptable items, which are removed for separate recycling or proper disposal. Waste is then pushed into a storage pit and thoroughly mixed before being loaded into bins, which we call hoppers, where it travels to the combustion chamber. The tipping and waste storage areas are maintained under negative air pressure to contain dust and odors. Once fed into the combustor chamber, waste is combusted at extremely high temperatures in a self-sustaining process at approximately 2,000 degrees Fahrenheit. A typical hopper load is completely combusted in 1 to 2 hours. As the waste is burned, the heat converts water in the steel tube-lined walls into steam that rises through boiler tubes where it is superheated. The steam turns a turbine-driven generator to produce electricity, or may sometimes be used directly for heating or industrial processes. The electricity produced by the turbine generator is exported to local utilities for use in homes and businesses. Each ton of waste can generate 550 to 700 kilowatt hours of electricity. Steam from the process is condensed back into water and returned to the boiler tubes, making it an efficient closed-loop system. After combustion, the volume of waste is reduced by 90%, leaving an inert ash and metal. Collected metal is sold to be made into new products. Remaining ash is beneficially reused or landfilled as non-hazardous waste. Ferrous metals such as iron and steel are recovered using a rotating drum magnet, and non-ferrous metals like aluminum and copper are separated by an eddy current system. State-of-the-art air pollution control equipment ensures that emissions are well below limits to be fully protective of human health and the environment. We neutralize acid gases using lime in a scrubber reactor and inject activated carbon for heavy metal control. We control emissions of particulate matter primarily through a baghouse, which employs thousands of fabric filter bags. All flue gas must pass through the bags before exiting through the stack. Throughout this process, the control room closely monitors emissions through a real-time continuous emission monitoring system, controls steam flow, and manages a number of other automated systems inside the facility. Waste-to-energy is widely recognized as a technology that helps mitigate climate change. In fact, waste-to-energy facilities are the only form of energy generation that actually reduce greenhouse gases. This is due to avoiding methane from landfills, offsetting emissions from fossil fuel electrical production, and recovering metals for recycling. We hope you enjoyed the tour.